quadrilateral having both pairs of opposite sides parallel is called a parallelogram. A quadrilateral with two pairs of parallel sides is a parallelogram. When given a parallelogram, the definition and theorems are stated as: a parallelogram is a quadrilateral with both pairs of opposite sides parallel. If a quadrilateral is a parallelogram, the two pairs of opposite sides are congruent. The proof of this I will be giving. Actually, I will be giving the proof of opposite sides and opposite angles of a parallelogram are congruent and diagonals of a parallelogram bisect each other. If a quadrilateral is a parallelogram, the two pairs of opposite angles are congruent. If a quadrilateral is a parallelogram, the consecutive angles are supplementary. If a quadrilateral is a parallelogram, the diagonals bisect each other. If a quadrilateral is a parallelogram, the diagonals form two congruent triangles. 6 properties of parallelograms. Opposite sides are parallel. Opposite sides of a parallelogram are congruent. Opposite angles of a parallelogram are congruent. Diagonals of a parallelogram bisect each other. Consecutive, that is, same side interior angles are supplementary. Either diagonal separates the parallelogram into two congruent triangles. Property: each diagonal divides the given quadrilateral into two congruent triangles. Diagonals bisect each other. The two diagonals are equal in length. The diagonals are perpendicular to each other. You know the types of parallelogram I have taught you in the previous class. Rectangle, rhombus, square are all parallelograms. All rectangles are parallelograms, all rhombus are parallelograms, all squares are parallelograms. But all parallelogram need not be a rectangle, all the parallelograms need not be rhombus, all the parallelograms need not be a square. But all rectangles are parallelograms, all the rhombuses are parallelograms, and all the squares are parallelograms. So if you are asked to write the types of parallelograms, so types of parallelogram will be rectangle, rhombus, and square. Now let us see the property of each and everything: parallelogram, rectangle, rhombus, and square. Now each diagonal divides the given quadrilateral into two congruent triangles. S for parallelogram, S for rectangle, S for rhombus, and S for square. So this property is there for all the four figures: parallelogram, rectangle, rhombus, and square. Now see the second property: diagonals bisect each other. For parallelogram, for rectangle, for rhombus, and for square, diagonals bisect each other. Now see the third property: the two diagonals are equal in length. For rectangle and for square, this property holds. But for parallelogram and rhombus, this property doesn't hold. The two diagonals are equal in length holds for rectangles and squares. Now coming to the fourth property. The diagonals are perpendicular to each other. It holds only for rhombus and squares. Now, the diagonals are perpendicular to each other holds only for rhombus and square. It doesn't hold for parallelogram and rectangle. So now once again I am repeating the property of parallelogram, rectangle, rhombus, and square. If you take parallelogram, each diagonal divides a quadrilateral each diagonal divides the given quadrilateral into two congruent triangles holes. For rhombus, each diagonal divides the given quadrilateral into two congruent triangles holes. And for square also, each diagonal divides the given quadrilateral into two congruent triangles holes. Now coming to the next one. For parallelogram, diagonals bisect each other. For rectangle, diagonals bisect each other. But this property holds for all the four, rhombus also and square also. For rhombus also, diagonals bisect each other. For square also, diagonals bisect each other. Now coming to the third one. Only for rectangle and square, the two diagonals are equal in length. Now coming to the property 4. For rhombus and square, the diagonals are perpendicular to each other. Now Venn diagram for parallelograms. Label each figure with one of the following terms so that the diagram represents the relationships between the different types of polygons: quadrilaterals, parallelograms, rectangles, rhombuses and squares. Now, all parallelograms are also quadrilaterals. All the rhombuses are also quadrilaterals. All the squares are also quadrilaterals. All the rectangles are also quadrilaterals. Under parallelograms we have rhombuses, squares and rectangles. Rhombus, square, rectangle are all types of parallelograms. Now when you talk about quadrilaterals, it has 4 sides, 4 angles and angles add to 360 degrees. When you talk about parallelograms, opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles add up to 180 degrees, diagonals bisect each other. Now, under parallelograms we have rectangle, square and rhombus. So when you are talking about rectangle, all angles are congruent, diagonals are also congruent. When you are talking about rhombus, all sides are congruent, diagonals are perpendicular, opposite angles are bisected. And square contains all these properties, everything. All angles are congruent, diagonals are congruent, all sides are congruent, diagonals are perpendicular, opposite angles are bisected. So it is shown neatly in a Venn diagram. So we can follow this. Now coming to theorem 1. Opposite sides and opposite angles of a parallelogram are congruent. You are given ABCD is a parallelogram. That means side AB is parallel to side DC, side AD is parallel to side BC. You have to prove opposite sides and opposite angles of a parallelogram are congruent. So you have to prove opposite sides and opposite angles of parallelogram ABCD are congruent. So in order to prove that, you have to notice from the figure segment AD, you have to prove it congruent to segment BC. Segment DC, you have to prove it congruent to segment AB. You have to prove angle ADC is congruent to angle CBA. And also you have to prove angle DAB is congruent to angle BCD, because you have to prove opposite angles of a parallelogram are also congruent. So you are going to prove two things here. One is opposite sides of a parallelogram are congruent, and the second thing is opposite angles of a parallelogram are congruent. So now we have to prove segment AD is congruent to segment BC, segment DC is congruent to segment AB, angle ADC is congruent to angle CBA, and angle DAB is congruent to angle BCD. Now look at the construction here. Simply with a parallelogram we cannot do anything. Now we have to prove so much, so we have to draw at least one diagonal AC. So we are drawing diagonal AC. Now coming to the proof. Segment DC of congruence, you can use any one of the tests which is fitting over here. We already proved equation 1 and 2. Look at equations 1 and 2. The second equation is angle DAC is congruent to angle BCA. The first equation is angle DCA is congruent to angle BAC. And also we have the common side. Segment AC is congruent to segment CA. See, vertex A is corresponding to vertex C, vertex D is corresponding to vertex B, and vertex C is corresponding to vertex A. Because if you cut these two triangles, cut along AC, you will get two triangles and try to overlap them. Then A will overlap with C, vertex D will overlap with B, and vertex C will overlap with A. So the common side is segment AC is congruent to segment CA. A falls on C and C falls on A, no? So segment AC is congruent to segment CA. The reason is common side. Now, the side is an included angle between the two. Sorry, side is the included side between the two angles. Look at the figure. Side AC. It is the included side between the two angles, angle DAC and angle DCA. Look at segment CA, that's the same side only, CA. It is an included side between the angles, angle BCA and angle BAC. Hence, by ASA test, these two triangles are congruent. Triangle ADC is congruent to triangle CBA by ASA test. Triangle ADC is congruent to triangle CBA by ASA test. Now, corresponding sides of congruent triangles. The remaining overlapping sides you have to take. Pairs of overlapping sides. Side AD is congruent to side CB and side DC is congruent to side AB. Because A corresponds to C, D corresponds to B. So side AD is congruent to side CB and side DC is congruent to side AB. These are the remaining corresponding sides of the congruent triangles. Now, let us see what is the remaining corresponding angles of these congruent triangles. Angle ADC and angle CBA, they are left out, no? In the figure you can see. So, angle ADC is congruent to angle CBA. The reason is corresponding angles of congruent triangles. Similarly, we can also prove angle DAB is congruent to angle BCD by drawing the other diagonal BD. So, when you draw the other diagonal BD, then you can similarly prove angle DAB is congruent to angle BCD. When we drew the diagonal AC, then we had proved angle ADC is congruent to angle CBA. If you follow the same procedure with the other diagonal BD, then you can prove angle DAB is congruent to angle BCD. Hence, we have proved segment AD is congruent to segment BC, segment DC is congruent to segment AB, angle ADC is congruent to angle CBA, and angle DAB is congruent to angle BCD. So, we have proved that opposite sides and opposite angles of a parallelogram are congruent. So, after finishing this theorem, you have to write that statement. Hence, we prove opposite sides and opposite angles of a parallelogram are congruent. Now, coming to the next theorem. Diagonals of a parallelogram bisect each other. Diagonals of a parallelogram bisect each other. Look at figure 5.9. It is there in your textbook. Figure 5.9. Given quadrilateral PQRS is a parallelogram. parallelogram. Look at the figure. We have the parallelogram PQRS. Diagonals PR and QS intersect in point O. We have to prove diagonals of a parallelogram bisect each other. So we have to prove segment PO is congruent to segment RO and segment SO is congruent to segment QO. We have to prove that diagonals of a parallelogram bisect each other. That is to prove here what are the diagonals PR and QS. So we have to prove that segment PO is congruent to segment RO and segment SO is congruent to segment QO. Now coming to the proof. In triangle POS and triangle ROQ, we have drawn both the diagonals because it is given diagonals of a parallelogram bisect each other. So we have to construct both the diagonals. So we get now take these two pairs of triangles, triangle POS and triangle ROQ. You can see that angle OPS is congruent to angle ORQ because they are alternate angles. OPS and ORQ are alternate angles because PS is parallel to QR and line PR is the transversal. Then you can apply the alternate angles theorem and say angle OPS is congruent to angle ORQ. Now side PS is congruent to side RQ because they are opposite sides of a parallelogram. Opposite sides of a parallelogram are congruent. Opposite sides of a parallelogram are congruent. So side PS is congruent to side RQ. Now coming to the next one. Angle PSO is congruent to angle RQO. So if you are taking PS to be parallel to QR, already it is a parallelogram, so PS is parallel to QR, opposite sides are parallel, and let us take line QS to be the transversal now. When you take line QS to be the transversal, the alternate angles are angle PSO and angle RQO. So angle PSO is congruent to angle RQO because when the lines are parallel, the alternate angles are congruent by alternate angles theorem. So now we get angle PSO is congruent to angle RQO. Now look at the figure. Look at those two triangles, triangle POS and triangle ROQ. In that we have two angles and an included side. Angle OPS is congruent to angle ORQ, side PS is congruent to side RQ, angle PSO is congruent to angle RQO. So we take triangle POS and see whatever we have considered, angle OPS, side PS and angle PSO. Side PS is the included side between the angles OPS and PSO. Similarly, in the other triangle, side RQ is the included side between the angles ORQ and RQO. So, by ASA test, angle side angle test, side is the included side between the two angles. ASA test can be applied here. So, by ASA test, we get triangle POS is congruent to triangle ROQ. Now coming to the corresponding sides of congruent triangles, that is CSCT. In short form we can write CSCT, corresponding sides of congruent triangles. So the remaining pairs you have to see. Cut the triangle and place one over the other in the mind and see. Segment PO will be congruent to segment RO because P corresponds to vertex R, O corresponds to O and Q corresponds to S. So segment PO is congruent to segment RO and also segment SO is congruent to segment QO. The reason is corresponding sides of congruent triangles. Now we each other. So finally you are to write, hence diagonals of a parallelogram bisect each other. So today we have proved two theorems. This is the second theorem, diagonals of a parallelogram bisect each other. Please learn the proofs of the theorems. It is very important to learn the proofs of the theorems. And statements also you have to keep in mind. When you are solving problems, it will be useful. When you are applying, when you are doing problems, it is application of all these theorems. So you have to keep in mind the statements also. So today we have proved two statements. The first statement was opposite sides and opposite angles of a parallelogram are congruent. And the second statement is diagonals of a parallelogram bisect each other. And always remember these points. Adjacent angles of a parallelogram are supplementary. Opposite sides of a parallelogram are congruent. Opposite angles of a parallelogram are congruent. Diagonals of a parallelogram bisect each other. So these properties are going to be used when you are solving some solved examples